It is Miss Moncrief again. Now this is kind of bittersweet because this is likely the last video I will ever make for you all, and you will then all move into your sophomore year and go do all your sophomore things. Anyways, it's just about operations with radicals. So we're going to learn how to add radicals, subtract radicals, multiply radicals, and I'm not going to teach you how to divide radicals. That doesn't seem like fun today. So let's get to it. So let's start with looking at adding and subtracting radical expressions. In order to add or subtract radicals, you need to have this thing called a like radical. So like radicals can be combined, which means they can just be added or subtracted. So like radicals just means they have the same root, same radicand. That means the same numbers inside the radical. That's all that means. Unlike this one, we have 3 square root of 5 and negative 7 square root of 5. They both have the square root of 5, so they are like radicals. And then unlike radicals would be like 4 square root of 3 and 4 square root of 5. Is the number the same on the inside of the radical? No, so they are unlike. So now let's get into it. Let's look at some adding and subtracting. Woo! All right, let's get going. So the first one, we have the square root of 3 minus 5 times the square root of 3. First of all, do they have the same number in the radical? Yeah, they do. They both have the square root of 3, so we're cool there. We can combine them. Now, when they have the same radical, it's much like combining like terms. So if I gave you x minus 5x, what would you do? Well, you knew there'd be a 1 there, and then you do 1 minus 5. What's 1 minus 5? Negative 4, so we're left with negative 4x. Now let's see how that applies. Now the square root of 3 minus 5 times the square root of 3. What number can we always say is there? 1. We do nothing with the radicals. We leave them. So now we have 1 square root of 3 minus 5 square root of 3. So we do absolutely nothing with the radicals. We leave them. Ignore them. And we'll just subtract those numbers, or we'll combine those numbers on the outside. So it's 1 minus 5. 1 minus 5. Well, that is negative 4. And we're left with negative 4 times the square root of 3. And that is our answer. That's all you gotta do. Just think of it as combining like terms with variables. Now let's look at B. B adds a little bit of extra first. So B says 5 times the square root of 3 minus the square root of 12. Now, I know what you're thinking, Miss Moncrief, those aren't the same, so we can't combine them. We're done. But I'm sure you also notice that we have all this other information here, which means we continue on. One thing we need to remember to do is simplify the radicals, then add or subtract. Remember, I did the video on simplifying radicals a lesson or two ago, so we're going to bring that back. So we have 5 square root of 3. What are some factors of 3? Well, just 1 and 3. So is that simplified? Yes, we're done there. What about 12? What are factors of 12? Well, we know some are 4 and 3. So we really have 5 times the square root of 3 minus the square root of 4 times 3. Can we break the square root of 4 and 3 down? Yeah, that's really the square root of 4 times the square root of 3. So now we have 5 square root of 3 minus the square root of 4 times the square root of 3. What is the square root of 4? Well, that'd be 2. So we have 5 square root of 3 minus 2 square root of 3. Now, do they both have the same radical? Do we have like radicals? Yes, we do. We have a 3 and a 3. So we'll just subtract those numbers on the outside, 5 and negative 2. So what's 5 minus 2? Well, that is 3, and we're left with 3 times the square root of 3. All right, so don't write it completely off yet if it looks like they don't have the same radical. Break it down first, and let's see if it does. So let's look at C. We have 4 square root of 7 plus 2 square root of 28. Now, right off the bat, you probably want to just stop because they don't have the same radical. Well, no, let's see if we can break down the square root of 28 any. Truly? Let's just break it down. What are some factors of 28? One of them needs to be a perfect square. So let's start with 28. Or we can go here. Y equals 28 divided by x. second graph. Now let's go up further. Starting at 0. Is 1 a perfect square? Yep, and that's 28. Keep going. Is 2 a perfect square? No. 3 is not. What about 4? 4 and 7. So let's simplify by using this, by saying 28. The square root of 28 is really the square root of 4 times 7. So we have 4 square root of 7 plus 2 the square root of 4 times 7. Can we break down the square root of 4 times 7? Yes. So we have 4 times the square root of 7 plus 2 times the square root of 4 times the square root of 7. Can I simplify either of those? Well, yeah, the square root of 4 is 2. So now I have 2 times 2, which will get me 4. So I have 4 square root of 7 plus 4 square root of 7. Now, do they have, like, radicals? Yeah. So just combine their outsides with 4 plus 4. Well, that would be 8. So we have 8 square root 7. And that's all you have to do. That's how you do it. Alright, now let's look at D. We have 5 times the square root of 32 minus 4 times the square root of 18. Now, first of all, do either of those look like they are the same? No, so let's break them down. Let's start with the square root of 32. And we'll do that over here so we don't have to write all of that good stuff out. So go to y equals, clear it out, and do 32 divided by x. And let's go where we have one of them needs to be a perfect square. So let's start with only one's a perfect square, and only gets 32. Let's keep going. 4, is that a perfect square? Yeah, and we get 8. Let's see if we have any other perfect squares. 8's a perfect square, and we get 4. All right. What's my next perfect square? Oh, 16. 16's a perfect square, and we get 2. So that means really we have the square root of 16 times 2, or square root of 16 times the square root of 2. Can we simplify either of those? Yeah. Square root of 16 is 4, so 4 times the square root of 2. So that means we have 5 times 4 times the square root of 2. And let's go ahead and simplify the other side. So what about the square root of 18? Let's see what that is. 18 divided by x, second graph. And let's go back up to 0. So we want to look at what's the highest perfect square that can go into 18. Well, 1 can go into 18, but it just has 18. So let's keep going. What's the next perfect square? 4, well, but that's 4.5. We don't want it. What's after 4? 9. And what do we have? 2. So let's do the square root of 9 times 2. And then I can simplify to the square root of 9 times the square root of 2. And then what's the square root of 9? Oops, forgot the 2. So we have 3 times the square root of 2. So minus 4 times what we had at the end. 3 times the square root of 2. Now let's start by, obviously, I bet you all are thinking it. Let's distribute. So what's 5 times? When we distribute, we'll only multiply by the number on the outside of the radical. So what's 5 times 4? Well, that gets us 20 times the square root of 2. And then what's negative 4 times negative 3? Well, that's negative 12 times the square root of 2. Any like terms we got there? Do we have like radicals? Yes, so we can combine those. What's 20 minus 12? And that'll get us... Mine went blank. Oop. Second mode. Clear. 20 minus 12. And what do we get? 8. So 8 times the square root of 2. And there you go. That's what we got. You can always check them by putting in what you got at the beginning and what you got at the end. So if you have 5 second square root 32 minus 4 second square root 18, what do we get? This ugly decimal times 8 second square root 2. And we got the same decimal. So we're great. And that's how you add and subtract radicals. All right. Now that we've talked about adding and subtracting radicals, we obviously want to talk about multiplying them. So when it comes to multiplying radicals, we want to use the distributive property, double distributive property of the generic rectangle. All that means is we're multiplying. So, we'll get to the double distributive or the generic rectangle when it comes to having binomials. So now then we'll want to simplify the radical and then combine terms. So if I have the square root of 10 times the square root of 6 plus 3, we'll start by distributing, which means we'll have the square root of 10 times the square root of 6. There it is, and then the square root of 10 times 3. So that'll leave me with, which is on this side, now we'll have to do the square root of 10 times 6. Well, that just means we'll multiply the numbers on the inside of those radicals, which is 10 times 6, 60. So we'll have the square root of 60 plus, and then we'll have the square root of 3 times 10. You'll only really just plop that 3 in front like a coefficient in front of a variable. Since they're both not in a radical, you can't multiply. You can't multiply inside the radical. So now we're left with 60, square root of 60 plus 3 times the square root of 10. Well, now we want to see if we can simplify those. We want to simplify either of those. Let's see if we can simplify 60. So it's my highest perfect square that can go into 60. Well, that's 4. So 4 times the square root of 15 plus 3 times the square root of 10. Square root of 4 is 2. So we have 2 times the square root of 15 plus 3 times the square root of 10. And we can't really simplify it any further. And that's what we got. So really, you'll just distribute, simplify, and combine. Distribute, simplify, and combine. Not too bad. Let's get another one. We have 6 minus 2 times the square root of 3 times 6 plus the square root of 3. We'll start by just distributing. This one, it's 2 binomials, so we kind of FOIL. So now we have 6 times the square root of 6, which gets us the square root of 36. Then we have the square root of 6 times the square root of 3. Since those are both on the inside of the radical, we'll multiply those numbers with 6 times 3, 18. So we'll now have square root of 36 plus the square root of 18. The next thing, we'll have negative 2 times the square root of 3 times the square root of 6. So there is no number on the outside to multiply by the negative 2, so we just have negative 2, and then we do 3 times 6, so times the square root of 18. And then lastly, we have 2 square root of 3 times the square root of 3, which gives us negative 2 times the square root of 9. So from there, let's simplify some stuff. First off, what's the square root of 36? Well, that's just 6. Can we simplify the square root of 18? No, we can't. Oh, no, but what about this? Square root of 18 minus 2 square root of 18. Can we combine those? Yeah, that'll give us a negative square root of 18. And then can we simplify the square root of 9? Yes, that gets us 3. So we have 6 minus the square root of 18 minus 2 times 3. What's 2 times 3, though? Gives us negative 6. So we have 6. And then can we simplify the square root of 18? Well, yeah, the square root of 18 is just the square root of 9, square root of 2. So we have 6 minus the square root of 9 times square root of 2 minus 6. And then let's see if we can simplify the square root of 9. Well, yeah, that's negative 3. And times square root of 2, well, that's negative 3 times the square root of 2. Oh, let me rewrite that. Negative 3, square root of 2, minus 6, and then, of course, plus 6. Can we combine any like terms? Yes, 6 and negative 6, and that gets us 0. So we're just left with negative 3 times the square root of 2. All right, let's keep going. Let's look at B. So we have the square root of 2 times the square root of 6 plus 5. So let's start by doing the square root of 2 times the square root of 6. Well, they both have a radical, so we'll just multiply those numbers with 2 times 6. Well, that is 12. Now we'll do the square root of 2 times 5. So that'll get us plus.
Third lunch, Blue Avenue.
5 times the square root of 2. And you might be thinking, I think I'm done. No, remember, we need to simplify the square root of 12. And let's first see if it is perfect. I know some of you are probably thinking, no, it's not, and you were right. So let's simplify the square root of 12. So y equals, we'll do 12 divided by x, and let's go to our table. We want the highest perfect square. So let's go to the first one, which would be 1. That just gives us 12. Let's keep going. What about 4? Yeah, and that gets us 3. I think that's as high as we're going to get. So we'll have the square root of 4 times the square root of 3. What's the square root of 4? Well, that's just 2. So we have 2 square root 3. So that means we have 2 square root 3 plus 5 square root 2. And those can't be simplified any further because do they have like radicals? No. So we're good. All right, now let's look at C. C, we have 11, the square root of 11 minus 2 squared. So the first thing we want to do, of course, because it's squared, is write it out twice. Very good. So we have the square root of 11 minus 2 times the square root of 11 minus 2. So the first thing we need to do is the square root of 11 times the square root of 11, which is the square root of 121. And then we have the square root of 11 times negative 2, which really just gets us negative 2 square root 11. We have negative 2 square root 11, which gets us another negative 2 square root 11. We have negative 2 times negative 2, which gets us a positive 4. What's the square root of 11? Square root of 121? Well, that's just 11. Can we combine these two terms? Yes, because they have the same radical. So what's negative 2 minus 2? Well, that'll get us negative 4 times the square root of 11. And then bring the 4 down, so plus 4. Anything else we can combine? Yeah, that 11 and that 4 back here. Should just be a 4, sorry. 11 plus 4, well, that's 15. So we have 15 minus 4 square roots of 11. And there you go. That's all you gotta do. I think that one might have been our easiest one. I don't know. Alright, and now let's go into a really kind of yucky looking one because we got so much going on. D, we have the square root of 6 minus 2 square root of 3 times 4 square root of 3 plus 3 square root of 6. Again, we're going to start by just distributing and foiling. So what's the square root of 6 times 4 square root of 3? Well, we're just going to multiply the outside. So what's 1 times 4? Well, that'll be 4. And multiply the insides with 6 times 3. Well, that is 18. Yeah, that's 18. And then we'll do the square root of 6 times 3 square root of 6. Outside, 1 times 3 is 3. So plus 3, and then the square root of 6 times square root of 6 is 36. Very good. And now I'll do this one. Negative 2 square root of 3 times 4 square root of 3. Multiply the outside. 2 times 4 is 8, so plus 8. And then square root of 3 times square root of 3, which will get us 9. And then again on the last one, negative 2. Ooh, I forgot that was negative. Let me change the sign super quick. This should be a negative 8. Then negative 2 times 3 should get me negative 6. And then square root of 3 times square root of 6 should get me the square root of 18. Alright, so what we can do is start simplifying some of these radicals. Let's start with this 4 square root of 18. Let's start with the square root of 18. We know that y equals, clear this out, divided by x. Second graph, go to the highest one. 1. I think we can go further. The next would be 4. That's a decimal. And now let's go to 9. Well, yeah, that's 2. So we have the square root of 9 times the square root of 2, which is really just 3 square root of 2. So we have 4 times 3 square root of 2. And then plus, what's the square root of 36? 3 times 6 minus 8 times the square root of 9, which is 3. And then we have minus 6 times, and then again, what's the square root of 18? 3 square root of 2. Now let's do some more multiplication. What's 3 times 4? What's 4 times 3, which will get us 12 square root of 2, plus what's 3 times 6? Well, that's 18. Minus 8 times 3, well, that I think is 24. Ooh, yeah, 24 minus 24. Minus 6 times 3 would be 18 square root of 2. Let's find some like terms we can combine. Well, we know we can combine 12 square root of 2 with negative 18 square root of 2 by combining that 12 and that 18. And what do we get? 12 minus 18. Ooh, delete. Is negative 6. We have negative 6 square root of 2. And then we can combine 18 minus 24. So what is 18 minus 24? And we get negative 6. We have negative 6 square root of 2 minus 6. And there we go. That's all you have to do. If you have any further questions, you can contact your teacher. I'm sure she'd be happy to help. All right, y'all have a lovely day.